Hi, my name is Baxton Achieng. Welcome to Beginner Series 014, where today we are going to learn about the traditional dimension paper, also the abbreviations that are used in taking off or measurement for that matter, and also we are going today to also learn now the measurement, which is now the one-on-one taking off that has been long awaited. Before we indulge into that, I would urge you that please make a subscription to this channel so that you don't miss any of these interesting episodes that I've started streaming in, because I can assure you that you are going to benefit from it so much. Welcome to the session, and I hope you will learn a good deal in terms of what we are intending to cover today. Welcome. Traditional dimension paper, as has been presented there, is now as the name suggests, are the papers that are specially made or ruled for that matter, and then they are relied upon in terms of taking off. Despite the many or much indulgence into technology that has come into place, where the measurement or the taking off is being done electronically or using the technology, the traditional dimension paper still stands out. And for that reason, you realize that when you have the idea of using the traditional dimension paper, taking note of the principles that are applicable, then you are at a good place. It means you can handle any other job with any other technology, as long as you are also able to learn from it. That means that the traditional dimension paper, or the traditional way in which you are doing your taking off, can set a good precedence on how you are moving forward in terms of doing the other jobs, even if despite which kind of technology is available for you at your disposal to use. So the idea here and the concept that the traditional paper we are going to learn is so crucial, and as the reason as I've just said. So as we are moving on, we are tending to leave alone much of the theoretical concepts, because now we are starting now to cover the actual taking off, or you can also call it measurement for that reason. So as we are starting today, I would like us just to study what we call the traditional dimension paper, know some of the parts that it has, okay, and also how to use it, so that when we now start taking off, it will be easier for us, because we know where do we write what, or the dimensions, where do we write them, and then each of them, what does it signify when you do them in that particular order. So that said, we like to learn first of all now the parts, and as they have been numbered there, they are usually not numbered, but then they have just been given that for identification. Okay, so when you go to item column 1, so those are now columns. They are just basically defined using lines. Column 1, 2, okay. Then we have 3 and 4, okay. Yes. So that is how they have been identified for this order, okay. We are talking about 1, we are talking about 2, we are talking about column 3, then we are talking about column 4, okay. So these ones are identified. You can identify these as page 1, okay, because you realize that as they are numbered there in those particular columns, they are signifying different pages, because you realize that what you have on your left, on the left, is also what is replicated on the right, that is. So for that manner, you realize that we can have one side to be identified as a one page, and another side to be identified as a different page. So that said, this is 1, 2, 3, 4, and then we also have another 1, another 2, and another 3, and another 4. Okay, so what does each of them mean? Okay, if starting off straight away, we have column 1, okay. So we just want to see what does column 1 stand for. So column 1 in this case you will call it as a time missing column, and as we are moving on, we are going to see what the time missing means and how to use the same. So that is a time missing column, and then yeah, that is a time missing column. That is a column 1. All right, then we have column 2 called the dimension column. The dimension column. Then we have column 3, you call it squaring column. Okay, and then we have column 4, and you will call it waste. Okay, so you want to see each of these columns, how are they used and how are they important for us in our discussion and also in our measurement, the one that we are eagerly waiting to indulge into and do much of it. So the time missing column, we want to see now for dimension column, squaring column and waste column, how are they important and how are they used when you are a measurer or you are taking off for that matter. So let's see. Good. So as we move on, column 1, we've said it's a time missing column. So column the dimension column 2, which is the dimension column, is the one that starts. Okay. So for instance, when we have I'd like us to, before we get into now giving those particular columns, I would like us to see the various ways in which you can have the final product, that is now after doing what we call the squaring, in the various ways, so that we enter dimensions in regard to that order. Okay, so let's just see forms in which you can have the quantities. Forms in which you can have the quantities. Okay, so let's see what are the possible ways in which you can have the quantities. The quantities, now I'm telling you, is what is going to be on your column 3, that is the squaring column. So once you squared, what are the possible quantities that you can have in terms of the units? So that said, the possible quantities would be let me just do this. At number 1, you can have cubic. Okay, cubic quantities, that is now in cubic meters. You can have it that way. Then 2, you can have square meters or superficial square meters. Okay, I would rather use the other symbol, that is cubic meters. Then I use square meters. Then 3, you can have numbers. Okay, now these are the ones that we said you can do what you call enumerated. For those that items that the standard methods is stating that you need to do the measurement in square meters. So in that case, then you can have what we call numbers. Okay, then you can also have items. Okay, there are those items, for instance, when you're talking about the substructure levels. We'll come to see that later on when we start to do now the search to interact with the search items, which is probably might not come in this session because we have much to cover in this introductory session in as much as the traditional dimension paper is concerned. But then when we start to do the measurements or the taking off, you are going to be able to see those all these items that we are talking about. So there is a fifth one. We have cubic meters, square meters, numbers, items, and let's see what we are missing out. Just a minute. What we are missing as the fourth item, no, I mean the fifth item should be linear meters. Perfect. So what we have next is the linear meters. That is the fifth item. Okay, linear meters, or you can just abbreviate it as meters for that matter. Of course, the item, the abbreviation that is used is an item as it is. So that said, we like to see how those items can be entered in terms of entering in the dimension. And of course, we are going to now look into now those particular items, because we realize that in the building or in the construction, whatever we are going to do the measurements for, they are spread in quite a number of ways. So we are going to see into that even in more in-depth in that order. Nice. So as we go on, let's just see how now, for instance, you have an item that you need to express in cubic meters. We're just going to use figures that are going to be expressly, for example, so that you know in cubic meters this is the possibility of how I'm going to enter the dimensions, do the squaring or the timesing for that matter, and have our quantities in that particular unit. So that said, let's see. So we start with the first one. The first one is the cubic meters. So let's see, when we are supposed to express our quantity in terms of cubic meters, how are we supposed to do that? So the first one, we do the cubic meter that we've also abbreviated as cm. So let's see, cubic meters, we're just going to use figures for example purposes. So I would like to have, for instance, the length of for instance, we want to measure cubic meters of concrete. Okay, so an example here is a concrete volume. Okay, concrete pad foundation. These are concrete pad foundation, concrete pad foundation volume. Okay, that is supposed to be in cubic meters. So this is our example one. So in this case, let's see how you will enter the figures and how the possibility of how they will be arranged. So in this case, for instance, you're going to say your pad foundation is 1.20. Yeah, you have to remember that we agreed while we were going through the rules that you definitely need to express the figures in 2 decimal places. So when you have them in 2 decimal places, then that is what you're supposed to have. So this particular pad foundation is now, let me say, a square. Okay, so when it's a square, then let's see how it's supposed to be. So 1.2, another 1.20, then another, the depth, for instance, let's say it's 0.40 meters in depth. So you have that. So in that case, that is now the dimension column. The dimension column, you've entered the dimensions read directly from the plan. Okay, from the plan that you have. And example, I'll just show you. For instance, you have this plan. Okay, for instance, you have this, and in this case, you've just read your plan. 1.2 times 1.2, then the depth, for instance, is 0.4 meters. Okay, that is 400 millimeters in depth. So you've read that directly, and then you've entered the dimensions. Okay, once you've entered that, then you need to do what you call underlining. Okay, you need to underline this. That is what we said, and that is what the rule says. You underline that. Of course, you need to underline it fully from I mean that the all of that particular, say that, and yeah, that's okay. So all the figures, that line should be running across to cut to underline all the quantities that you've entered. So for you, that is now the dimension column has been utilized. For you to also utilize the timesing column, assuming that these are 4 pads, column, pad, foundation, 4 number, you can state that you have, for instance, you have 4 number concrete pad foundations. Okay, how you want to calculate their volume. So they are in 4 number, and how do you get that 4 number? You count them from your plan. Okay, the most reliable, of course, there are those engineers that will go an extra mile to give you the number of pad foundations on a particular foundation, but then the most reliable way for you as a quantity surveyor is to count. Do a physical count on that drawing that has been, on that design that has been done. Count those pad foundations, how many of them are available in that plan. So once you have that, there are 4 number, then you now want to utilize your timesing column. You are going to multiply by 4. Okay, so 4 times that. All right, so that is what you do. Well, so 4 number columns, the dimensions have been entered, and then now we are going to do our timesing column. So this means you have the first one is the 1.2 is the length, or because it's a square, so there is no much difference between the length and the width. But then if it was a rectangular pad foundation, then the first one would be your length, the longer one. Okay, so let me just okay, let's just first finish on this, then see. So the 4 times 1.2 times 1.2 times another 1.2. So that is now when you now utilize the third column, which is the squaring column. So you are basically multiplying all the items that you have in the dimension and also what you have at the what we call the square, the timesing column. So when you do that, then this line, okay, of course this is a word version, so the quantity should be here. So you have, let me see, just in a minute. Okay, there. So you have 4 times 1.2 times 1.2 times 0.4. So you do your calculation. You've multiplied the 4 times 1.2 times 1.2 times 0.4. Then you have 2.3. Okay, 2.30. Remember that those figures have to be in 2 decimal places at all times. So that is what is available. That is what you find. Okay, and that is where you need to write that particular dimension. So in that case, we have an expression of a cubic meter that I've shown you the use of the different columns of the traditional dimension paper. Okay, so just in a summary, we just want to write, for instance, what is the 1.2, what does it represent? So 1.2 in this case will represent our length. Okay, so whenever you are expressing any other figure in terms of that is going to lead you to getting your cubic meters, then the first figure is now going to be your length, and then another 1.2. Now that they are both 1.2, it's challenging, but then I can just write first 1.2 and then second. Yes, so this is just for you to guide you, so that you see the first one is the length, the second is now your width, and of course it's a square. So I told you that being a square, you are not able to identify which is the length and which is the width. Okay, but then you also remember that at first we say that the longer one, because in this case we don't have that debate of this has to be the length, this has to be the width. If it's a perfect rectangle, it's easier. The longer one is your length automatically, then the shorter one is your width. Okay, then the third item here, the 0.40 is your depth. Okay, in that order, and then the 4 is now the number. Okay, the number of, now those are the number of pads that we have. Okay, then the 2.30 is now the cubic meters. Okay, the cubic meters. So in that case, you have your expression in terms of the cubic meters, and you've seen, so the 4 which is lying at the timesing column is now the number of pads. So normally you will be putting the number of how many times that particular element is repeating on the building. So for instance, if you decided to use let me say to count the number of trees that you want to do in your substructure level, for instance, then the number of those trees, you count it as 1, and then the number you multiply by what is there. You're going to see that when we come to the numbers or the enumerated items. So we've seen that. Now that is what you need to express. But then you realize that there are other features that are also necessary, so that we can just explain this once and for all. In this case, there are other elements that are involved. Okay, you realize that for instance, let me just bring them down a bit so that you see there is a concept to explain here. Let me just help you do this. Alright, so I want, okay, so the first bit, I was using it to help in explaining what we are talking about in terms of in terms of the figures, the length, width, and so on. So we use that first bit to express that. Then the second bit, I want us to use it to, let me just undo so that we don't confuse anything here. Just let me undo this very fast. Okay, so what we'll do, I'll just use it. So the first one, we were using it to express how to utilize those columns to do the cubic meters. Okay, so I'll just leave alone that. Then another concept is now that we are going to do is what we call bracketing. Okay, there's another concept of bracketing. So in this case, we've already shown our figures, dimensions for that matter. So I want to do, that is 1.2, another 1.20, then 0.40. okay, so we have that, and then of course we have the 4 multiplied by that, and then we have of course the 2.30. Do not forget to underline your work, the dimensions that you've entered. And the reason that underlining it is important is because it's defining that you are using all those 3 dimensions at once, so that they are going to lead you into what we call now the cubic meters for the item that you are measuring in that order. So that is quite important to note. Then of course this is now the timesing that we have, and that is how to express that, and the 2.3 cubic meters that we also have here. Perfect. So once we have that, we want to learn the concept of bracketing. Okay, so bracketing, you will do it in that order. Of course, once you have this, then you need to do your description. Okay, so we'd rather explain the description first. Okay, description in this order. So the column that we haven't utilized, we've done the timesing, dimension, squaring, and then we haven't utilized the fourth column, which is the waste calculation. So the fourth column where we have the waste calculation is basically for you to do your extra calculations. Okay, so just want to show you how that is done. Okay, so in your waste calculation, that is where you are making your extra calculations here and there, like for instance what is shown here. So you have the length written, the width written. If you're working up towards getting maybe a center line or a total length of an item, then that is where you need to do your calculations at the part called waste. And also your description is also expressed in that order. So let's continue. So let's just see how to work on that. So for instance, let's just show a little bit of calculation. Of course, here the items were straightforward, so you don't need to have, there is no much need of calculations needed there. So that is 1.20, and then we have depth is equals to 0.40. So in that case, it's basically you showing how these items that you've entered into the dimension and also the squaring column were arrived at. That is how that is done, and that is how you arrive to that particular point. So that is expressed well. So the other, okay, of course you've had now you've utilized all the columns. You've utilized the dimension, the timesing, and the squaring, and also the waste. Then now the final thing that you do there is now what we call description. Okay, so how do you put your description? So in this case, you are going to describe whatever that has been measured here. Okay, of course you see this is the 2.3 is now the final figure. It means you've already done all that you're intending to achieve. Once that is in order, then you need to do your description. So you will say vibrated, reinforced. Yeah, this was an example of a reinforced concrete pad. So vibrated, reinforced concrete. Talk about class. Yeah, you can say, for instance, class 25, class 2520. That is not the class of 25 with the aggregates of maximum of 20 millimeters diameter. So class 25 that in concrete foundation pads. Okay, it doesn't have to be underlined, so just do away with that. It doesn't have to be bold as well. So you have that, and then now do what you call you need to have now what we were saying at just in a moment ago about the so-called bracketing. So you need to have a bracketing, and the essence of bracketing means that you are trying to confine all that you are expressing at one particular point. All that, for instance, that the dimensions that you've entered and the quantity that you've got in cubic meters, what is it about, plus that description, so that you make the items to be one thing. So you do what we call bracketing. Yeah, that is what we'd like to see next. Okay, this is how the bracketing works. Once you've done your description and the quantities, you do the bracketing. So let's just also make ours so that that point is well taken in, and we alright. So in this case, being a word format, let's see what we can use now. Let's use a border. Okay, of course we can talk about another thick border here, so that it's, let's see how that can be gotten. Yeah, let's see if we can have a border there. Okay, being a line, it's let's see the options that we have, but we just need to see how to bring a line over there. Okay, we have one here, but it's lighter. It's of the same thickness as the other, it's the same thickness as what is existing for our lines. But then you note that we need to have a line there that is confining our description and also the quantities that we've worked out in that particular manner. So that said, then there is one more concept. So we've just in summary, we've talked about the columns, okay, and we've seen how the columns have been used. That is column 1, column 2, column 3, timesing, dimension, and the squaring. We've seen how that is used. We've seen how column 4 is used. That is on working out your waste and also doing your description. So we've also done our description there and done what we call bracketing. So those are the items that we've learned so far in this particular session. Okay. Then just let me say summary. We've done the columns. We've seen all of them, column 1, 2, 3, and 4. We've also done description. Okay, then we've also done okay. All right, so we've done columns, we've done description, we've also done bracketing. Okay, so there is one thing that is we would also need to look into today, and that is what we call, let's learn about dotting on. So this is also another concept that we need to learn from what we've done. So for instance, if you realize that let's just use the same bits that we have employed today, and that includes just, okay, let's just have our bits here, that the ones that we've used 1.2, another 1.2, and another the 0.4. We're just using what we've done, and of course the 4 that is also there. Let's see, okay, that is right, and then you underline that, and then we had our 2.30. yeah, let's just have it here, 2.30. Of course that is also underlined in that order. So we have that. So we are learning the concept of dotting on. Okay, so this is basically a concept of an addition to the timesing. Okay, for instance, when you've realized that you found out there were four number of column pads at first instance. Okay, but then when you go ahead and count again, then you realize that, oh well, I seem to have forgotten not to have counted one of the column foundation pads. So what do? You do what we call dotting on. Simply an addition to what you are supposed to use to do the timesing for the quantities that you've entered in the dimension. Okay, so it's as straightforward as that. So then dotting on, you can just do your definition. Yeah, defined as addition to the figure of timesing. I believe when you have it that defined as simple as that, you know where the timesing is, column 1. Okay, so you want to add to it so that you have, for instance, you are dotting on under this, and then we have to see how that is done. Okay, so in that case, let's just do it. You have a dot just as the name is suggesting, you have what we call, let's see if this is going to help us. Perfect, that is okay. So you have a dot over there, okay. So for instance, you are adding other two additional column pads, so it's 4 plus 2. So when you're doing your squaring, then you need to do 1.2 times 1.2 times 0.4 times into bracket 4 plus 2. So a dotting on is simply an addition to what you are using to do the timesing. So in this case, the 2.30 won't be the answer because you are now using 6 instead of 4. And then you do your multiplication, 1.2 times another 1.2, then times 0.4, okay, times 0.4, then you multiply by into bracket the 4 plus 2. So you've done the dotting on. So instead of the 4, you now have 6, so it's 3.46 in that particular way. So you have that well expressed in the cubic meter that you have in that particular manner, okay. Yes, and of course you will go on. The other things remain the same, whatever we've discussed in terms of having your description, having your waste and all other part. So we were just concerned about the dotting on bit, okay. So that is the one that we've explained with that particular order. So the other ones, of course, are similar in the sense that they'll remain the same to the way that I had explained previously. So we've learned quite a few items today, and that is on the traditional dimension paper. And let's see if at all there is any other bit that we need to cover for this particular session. And of course, let's see if let's just give an example for where we have an instance where we have square meters. So an instance where we have square meters, then you will be having basically 2 dimensions. For instance, you have the length as 6 meters, say 6.2, and then the width is, for instance, 4.20, okay. And you don't have a depth because in this case you are basically looking to get, you are targeting to get a square meters of that particular work, okay. And then of course you now do the 6.2 times 4.2, you have 26.04, okay. So this one here is now expressed in square meters. Of course, you'll have the rest of the items remain the same. Your description or your waste calculation and bracketing, all those concepts that you've learned. For instance, if these items were 2, then you do your timesing. So you do the 6.2 times 4.2 times 2. So that remains constant. But then now we are targeting to see forms how to achieve these quantities. We've achieved cubic meters by having 3 dimensions, okay. Then we've now achieved square meters by entering 2 dimensions, okay. So let's see with what we do to have the numbers. So for instance, when you are targeting the number, you've counted 1 2 3 4 trees. Just write 1, okay. And then we've said 4, so it's 4 times that, or let's use 5 so that you don't think that we are sticking to 4 for the other previous part that we've done. So we have, for instance, 5, okay. So in this case you have to underline, because now whatever that you are expressing is already complete as a dimension as it is. So the 1 times 5, then now in your squaring column you need to have the 5 5.00 in that case. So you have you have that well expressed. Well, so this one, the unit is the number, okay. So we've achieved cubic meters. These are the cubic meters that we were talking about. In this case we have cubic meters. Shouldn't be that way. Yes, and of course I don't want the underlining part, so I want it that way. So this is cubic meters, achieved well. Then we have square meters, also achieved. You must remember to underline, okay, and the other two must be underlined as well, so that you have complete dimensions. This is also underlined. So the other one is item. So item is an item as it is, okay. Just write, that is now the symbol for that. Just write the item in that order. So that is item, and of course you will do your description and any other item and bracketing, all the other functions or the other parts of the dimension paper that we've talked about remain constant. Then lastly, so this is the unit for this is item. So we've achieved number, we've also achieved item, and the remaining bit is what we call the linear meters. So linear meters, for instance, you've worked out your perimeter or the line, for instance, when you're doing the measurements for, let me say, the DPC. So in that case, you've seen that it's 20 meters. So 20.00, it's complete as it is, because you are expressing that expressing it in terms of linear meters. So when you're doing your this is 20.00, sorry. So you have that in terms of linear meters, and then now the unit is meters, okay. Well, just to summarize so that we finish up our session today, we've looked into various parts or various forms in which you can achieve how to use the use of the traditional paper, the traditional dimension paper, in terms of the columns. We've seen how they are used in terms of the dimension can be utilized to achieve these 5 parts or the 5 bits that are listed there: cubic meters, square meters, numbers, items, and linear meters. So that brings us to the end of our session today, and of course now we've exhaustively covered we've exhausted so much in terms of the traditional dimension paper, its use, the various parts that it has. So building onto it, then we need to cover now the next that we should cover before we now start the taking off is going to be on taking off abbreviations. So that should be our next session. We see how the abbreviations are done, how they are covered, or how they are expressed in terms of the dimension paper, or how they are used here, and then straight away we'll now go to taking off the using the drawings that are available. So thank you so much for watching this video, and I believe that it was quite helpful, and it will be very much impactful in terms of your desire to learn the taking off and all that it entails in for that matter. So thank you. Please make a subscription before you exit, because it's important, and you will get more in terms of learning from this particular channel. Thank you so much. Have a blessed time. See you in the next session.